Hey everybody, this is Alex Merced from alexmercedcoder.com. So just going to show you my website real quick. Again, I'm from alexmercedcoder.com. This is just sort of my my portfolio website, so you can learn more about me there. Okay, and you can kind of see my different GitHub projects and libraries I've written, my blog. But also you can find me at devnursery.com, and devnursery.com is a resource for learning about coding. So if you head over here, the video tutorials, you'll find lists and lists of videos, playlists, where I teach you all sorts of different languages and frameworks and whatnot. So the learning never ends. But what I want to do today is that it's 2022, and a lot of things, I don't want to say a lot of things have changed, but there's a lot of really cool tools out there when it comes to programming, especially in the JavaScript world. So I figured a new intro to JavaScript set of videos would be useful. But except this is not just going to be an intro to JavaScript. This is going to be an intro to JavaScript and Typescript. So as we go through each lesson, you'll learn how to do the thing in JavaScript and then see it applied in Typescript as well, because they're essentially the same language with minor differences. So this first video, we're going to explain sort of like, why do you care? What are the tools? And what is a programming language? Because this video series is going to really be meant for someone who's just kind of starting from zero, if you're a new programmer. Okay, so bottom line is this. At the end of the day, the only language that a code knows is machine code. So, because at the end of the day, that's all we're doing with programming. We're just trying to give directions to a computer to do certain things, to show a particular color on a particular set of the screen. But all the machine understands are zeros and ones. Okay? Now, writing directions like this for a human is pretty difficult. Okay? It's like trying to remember how to express anything in just zeros and ones is tedious and difficult. So generally what we do is we create abstractions. Abstractions are anything that takes something that's complicated and puts it in a simpler package. So we created programming languages. Okay, so the first sort of layer of abstraction, what it was called, is still called assembly language. Okay. Now again, if you were to program an assembly language, it would still be pretty hard. Okay, but the idea is that assembly language allowed you to express things but not have to write a bunch of zeros and ones. And just to kind of show you an example, because again, assembly language is still fairly difficult but better than a bunch of zeros and ones, this is what assembly language would look like. Okay, you're still writing fairly terse verbose, which means just very you're using a lot of text to do something simple code, but again, a little bit more informative than zeros and ones and zeros and ones. So that's like the first layer. But as the need to do more and more complex projects goes, you need bigger abstractions, because doing complicated things with something that's very low level, meaning very close to just writing a bunch of zeros and ones, is going to be pretty hard. And generally the way assembly language worked is that your computer's processor would read the processor. So essentially, like if I have an Intel processor, it kind of has its own way of reading assembly code and turning it into binary, aka machine code. If you had like a ARM processor or a Mac processor versus a Windows processor, all of these kind of had different ways of taking that assembly code. So it was really like an abstraction for the processor. Okay, and there was different versions of assembly code. That's why it was really hard to always have to program something for like a Mac and then Windows. Some things were available for Mac, some things were available for Windows, because the code was compiled to assembly for that particular chipset. But we needed something. We didn't want to have to write assembly code. So what we did is you started having a layer of compiled languages. Okay, so that would require a compiler. Okay, and now what a compiler is something that takes some other language and turns it into either like assembly or machine code for a computer to run. Okay, so that's what it does. It just takes some code, turns it into the target version of assembly, or turns it directly into machine code, and now the computer can run it. Typically, it's going to target assembly because just easier to write, easier to build that. Okay, and the particular the big languages that kind of fit into this next category, and this became sort of the mainstay was C and C++. Okay, C and C++, which at the time of its release was considered, wow, this is making life a lot easier. Okay, now our code is starting to look a lot more like writing words. Okay, so if I were to bring up a snippet of like C++, okay, so let's bring up some images. Okay, so like, you know, this is still maybe not the most straightforward thing to read in the world, but again, we're starting to get to the word where we're starting to use real words that kind of mean things, and it's not looking so bad. And it really isn't. Okay, like C, C++, like it's definitely a lot more complicated. You have to write a lot more code to do very simple things. But relative to writing like assembly or binary, it was a huge step forward. Okay, it's still very heavily used. So most of our operating systems are written in C++. Most of the tools that we use nowadays are written in C, C++. But then what happened is that, like, you know, let's say you're making like a website, or, you know, there's a lot of other things where you really just don't need the kind of still the level of complexity to be of writing the code that C and C++. You need something that's going to make taking these extra complicated things and make them simpler. So now you have a host of different languages. Okay. A host of different languages. Let me just get another box. That are either compiled. So you have languages that are like compiled, and they may be compiled to C++, which then gets compiled to assembly, or they might be compiled directly to assembly depending on the language. Okay, so but you have all sorts of other languages that get compiled still, and again, where they get compiled to, again, they could be skipping C++. You know, it just depends on the language, or they could be interpreted. And interpreted means instead of turning the code into machine code and then into like a file that you can just then an executable. So you ever seen those files if you're on Windows? You see these files with the extension like .exe, meaning executable. So this is a file that's already pretty much like machine code or assembly that can just readily be run. Okay, you don't need to do any further compilation. You don't need to change it to something else. And interpreted code is just where you have a program, okay, that reads and changes the code to machine code literally like at the time you run it. So when you run in JavaScript, which is what we're going to be learning, is an interpreted language. So when we run JavaScript files, literally a JavaScript interpreter is taking the code that we wrote and turning it into something the computer understands at the time that we run it. But this could be a whole slew of different languages here. Okay, the list is long, but just to kind of give you, JavaScript is going to be our particular target, but also popular ones are like Ruby, Python, PHP, Perl, Go, Rust, Java, C#, Scala. Even though Java and Scala, there's a little bit more nuances to how those work with the Java virtual machine, but that's a different story for a different day. Kotlin, why is it? It's not Spark. Swift, and so forth and so forth. There's a whole bunch more. Okay, so that's essentially like what a programming language is. It's just literally us writing directions to the computer. So notice this is high. So this is what's referred to as a high-level language, because the idea is that this abstracts over this abstracts over this. So the idea is that this is just a much, much cleaner, simpler version versus writing the real thing that the computer understands, this. But eventually everything becomes this, okay, some way or another. Okay, again, more than likely than not, somehow it's getting to assembly, and then the processor is taking it from there. Cool. So that's sort of how programming languages work. So at the end of the day, right now, when we're working in these high-level languages versus lower-level languages, so you can see C++ is lower level than many modern languages, but still higher level than running machine code. So it's all relative. we just write text. You're literally just writing like a text file in the same way you would write like if you're on Windows, you'd open up a software like a Notepad to just jot down some notes. That's literally all code is. It's just text in a file. And then that text in a file is going to get passed to a compiler or get passed to a interpreter and then, work its way down this list. So we can write code anywhere, any kind of text editor. Okay, but there are special text editors that are built for writing code. Okay, primarily we're going to be using Visual Studio Code. So I recommend heading over to, Visual Studio Code. So I really want code.visualstudio.com. That's the website. So you're going to want to download Visual Studio Code. If you head over to this website, code.visualstudio.com, it should automatically detect the operating system you are and let you just download it, install it. Okay, and then open it up. So what I did is I've opened up Visual Studio Code, and you can click here, File. If you are on Windows or Linux, I'm on Linux, you should see an open file, an open folder, which means you can open a particular folder on your computer, which is what I did. I have a folder called TSJS 2022, which is going to be the folder I'm going to work out of during these sets of videos. And if you're on Mac, there's just going to be a open command, which can open a file or a folder. So you can choose a folder, you can choose a file. What I recommend is creating a folder for working for this particular set of videos and just work out of that folder. And then when you open up VS Code, then just to give you a quick tour, essentially you have these buttons here to create a new file. And you can create a file of any type because, again, they're just text files. They're literally just a file where you're going to write text in. The only thing that makes it special is that we're going to pass this file to some sort of interpreter, compiler, that's going to turn it to something that the computer can then follow our instructions. Cool. And then we can create folders here, and so forth and so forth. And then this here, the search is for like looking through your code. So if you want to look through all your files for particular text, you can use that. This is for source control, a discussion for another day. Same thing with this, run debug. This probably won't be by default. This is like, what happens is that, see this little Tetris block here? You can add extensions to your VS Code, which are things that add functionality. Generally, when you're working on a new language, you want to add things. So like if you're working with JavaScript, you generally always want to look for an extension pack. So there's probably an extension pack. So if you just type in like JavaScript pack, okay, and you'll find some sort of JavaScript extension pack that has like lots of extensions you may want to use to make it easier to program in that language. Okay, and you would do the same thing for like TypeScript. So I would type in like TypeScript pack. Okay, and then you see what they have. Okay, but just download some TypeScript and JavaScript extensions. If you take a look, you can take a look at the review numbers and the number of downloads to kind of see like, hey, is this a typically used thing? Cool. There's that, and then again, a lot of this other stuff is just stuff from extensions I installed, so we won't kind of go into them. Same thing with like the colors. The colors is from an extension called Peacock that automatically colors my screen. So yours may not look quite as colorful as mine. But essentially that's all it is. Okay, it's just a file, it's just a place for us to edit our text. Okay. Now let's start discussing like how do you run JavaScript. So let me make another drawing. Okay, so when it comes to JavaScript, okay, there are multiple ways. Now, JavaScript was a language created in 1995 and famously in, I think it was 10 Days by Brendan Eich. So literally like Netscape Navigator was the browser for the internet back in the 90s. And they wanted some language so that way people can click on buttons and do fun things. And they're like, Brandon, go make a language. And they gave him 10 days and he came out with JavaScript. Notice 10 days. So the language was a little rough around the edges when it was first created, but since then it's evolved into a very powerful, very flexible language which you should learn. Okay, so we have JavaScript code, which is not the same thing as Java. Okay, actually the reason they called it JavaScript because they wanted people to confuse it at the time because Java was like spending millions and millions of dollars in promoting the language, and they wanted to kind of piggyback off that. There were lawsuits, so technically the name of the language is, the official name is ECMAScript. No one calls it that really, but that's technically the official legal name of the language, because it's owned by the ability to make the specification is controlled by the ECMA committee. The, I think it's like European Computer Manufacturers Association. Okay. Now JavaScript is great, and JavaScript has lots of features. Okay, but then what happened is that it doesn't have some things that kind of anchor it discipline-wise, like which we're going to refer to as typing. Okay, and you'll learn more about typing and see what it is later on. So Microsoft came out with a version of JavaScript called Typescript. It's essentially all the features and all the syntax of JavaScript. So if you know JavaScript, you know Typescript, plus a few features, so that way you can do what's called typing. And typing, what's going to do, it's going to just allow you to say certain things in your code about what you're trying to do. That's going to allow your editor to help you find bugs. And it's going to allow you to catch errors quicker. Okay, overall. So that's kind of the benefit of that. But at the end of the day, there's 3 places where you can run JavaScript code. Okay, so originally the place you could run JavaScript code was in the internet browser. So in your Chrome browser, in your Internet Explorer, your Microsoft Edge, Firefox, Brave, that's where you would run your code. Okay, so really JavaScript was originally intended to just be attached to a website, and it would just kind of assist the website making, like, again, making a button clickable, making a picture move, some animations, stuff like that. So generally, if you're using JavaScript to manipulate a website in the browser, this is generally what's referred to as front-end engineering. Literally, JavaScript is the only language that can be used in the browser, which is becoming less and less a true statement as we speak because of things like WebAssembly, but generally still a true statement. But then later on, Ryan Dahl made something called Node that allowed us to take our JavaScript and run that code outside of the internet browser. Okay, and that's called Node.js. Now, at the time that Node.js was created, there was a lot of things about JavaScript that just hadn't been figured out yet, like module systems, TypeScript hadn't been created yet, so forth and so forth and so forth. But Node.js gave us the ability to run the code outside of the internet browser. The benefit of being able to run your code like in just your normal computer is that now you have access to the computer's, like, networking. So that way, if you want to build like web servers, the file system, if you want to like write files, delete files, basically you have access to the power of your computer, and you can use JavaScript to tell your computer to do things. Okay, and this was really useful for creating servers, which is really the realm of the backend. Okay, because your server, you have your computer that is separate from like the user's experience of the website, and you need to write code to tell that computer what to do. Node.js. Ryan Dahl and friends decided to go for another round because TypeScript came out, and then also there was a language called Rust that if you were to write like a compiler in Rust, it's a lot faster. So they went back and wrote a new runtime called Deno. And notice it's just literally the letters in Node. I think they're just sorted. Okay, so what they did is they ran a sort on the word node, and it spelled it Deno. Okay, and then that's how they came up with the name, which is also backend. So JavaScript could be run in all 3 of these environments. We're not going to deal so much with the internet browser during these videos because I just want to focus on the language and what the language does. I do have videos on using JavaScript in the browser. Just look up any of my videos on DOM manipulation, DOM manipulation. And that's all about like the more specifics of JavaScript in the browser. Okay, but again, in any of these environments, we can run JavaScript. So again, this first video, it's gonna be very little on the programming, very much on the setup and just sort of like conceptual setup. But all 3 can run JavaScript files. Now, to run TypeScript originally didn't have its own runtime. Like really what you do with TypeScript, you write TypeScript, it then compiles to JavaScript because JavaScript is what you need to run in the browser. Okay, and in Node. So what you would do is you would use a TypeScript compiler to run the code in Node, and you'd have to have this thing kind of set up separately. But the nice thing about Deno is that Deno has the TypeScript compiler built in. So there's no longer really a need to take all those intermediate steps and do all that setup. It'll just work right out of the box with Deno. Okay, so just so you can kind of see sort of like the variations of the story with these different tools. But at the end of the day, all three of these are ways to run JavaScript code. So you write text in a file that fits the JavaScript syntax, just like you following JavaScript grammar, and any of these three tools will run that code for you. Okay, so we're going to focus on these two tools, Node and Deno. Node we're going to use primarily to run our JavaScript files. Deno we're going to use primarily to run our TypeScript files. Okay, so we're going to head over to node.js.org, and you're going to download the latest version. Okay, so download Node. And then you're going to download, head over to deno.land and install Deno. Okay. And once you have them both installed, you should be able to head over here in VS Code, and you'll see like a little terminal thing up here, new terminal. Now, what a terminal is what's referred to as the command line. The command line is a way of talking to your computer. Most of us are used to using the GUI, the graphical user interface. So technically, what we're doing is we're seeing all these visuals, like these visual icons that you might see like on the desktop. Let me just kind of actually get to the desktop. So you're seeing like these icons, and you click on them, and they open things. That's referred to as a graphical user interface. It's just one way of me interacting and giving the computer directions. Okay, but really the way the computer works is that it takes text commands. Really all that's happening is that when I click this visual here, okay, under the hood there are commands being sent to the computer via this command line interface. Okay, that's basically where we can enter commands. So getting comfortable with this is really, really helpful. Now, if you're on Linux or Mac, you're going to be using Bash or Zush, which are the same thing. Okay, for all intents and purposes, they're the same thing. Okay, and generally right over here, it'll tell you which terminal you're using. If you're on Windows, it's going to default to CMD or PowerShell, which is not the same thing. It's going to be slightly different. My recommendation to you is to download software called Git Bash. Okay, so you're going to download Git Bash. Just you see here, just install it for Windows. And then what you're going to do is you can create a new terminal. Okay, so you just click, see like this little arrow right here. You can see your different types of terminals. Okay, and then you would choose a Bash terminal. Oh, okay, or it'll say Git Bash. Okay, so that way you have access to sort of the same kind of terminal I'm using. So all the commands will match up. So cool. So if you have that set up, so you got your, if you're on Windows, you got Git Bash installed. If you are otherwise, you have your Visual Studio Code, you have your Deno, you have your Node. You're going to be set up for the remainder of this course. Now let's just double check that we have Deno installed. I should be able to type in Deno in my command line and just say -- version. That's going to be typically the way you check the version of something. You type in the command name and then -- version, and see I get the version 1.17.3, and then I'm going to check node -- version, and I'm running 17.3. So there we go. All well and good. So I think that's going to be where I'm going to wrap up this video, but now you're all set up for the remainder of the course. You have the right mind frame for this course. So I'll see you guys later on. We're going to start actually writing some JavaScript and TypeScript in the next video.